Hello, my name is Arpon Das. I am student of Alia University in Civil Engineering, second year, third sem, and I am a lateral student. The assignments about building materials and construction, and the topic is cement. And the assignment is given by our sir Mohsin Jamal. Let's start. Intro. Cement is an extremely fine material having adhesive and cohesive properties which provides a binding medium for the discrete ingredients. Cement is a product obtained by pulverizing clinker formed by calcinating raw materials preliminary consisting of lime CaO, silicates SiO2, alumina Al2O3 and iron oxide Fe2O3. When cement is mixed with water, it forms a paste which hardens and bind aggregates, fine or coarse, together to form a hard of durable mass called concrete. Cement used in construction industry can be classified as hydraulic and non-hydraulic. Hydraulic cement set and harden extremely fast in presence of water, and non-hydraulic cements are derived from calcinating of gypsum or limestone because they are products of hydration are not resist to water. However, the addition of pozzolanic materials can render the gypsum and make cement hydraulic. Thus, it will not set in wet conditions. It sets, it dries and react with carbon dioxide in the air. It can be attacked by some adhesive chemicals after setting, plaster or perish. The cement experience the extremometric chemical reactions when comes in contact with water. The cement is assumed to have a specific gravity of 3.15. Standard density of cement is 1440 kg per m cube and one bag of cement is of 50 kg. The volume would be 50 by 1440 is equal to 0.0347 m cube. Hence, volume of one bag of cement can be approximated of 0.035 m cube or 35 liter. Cement can be manufactured either from natural cement stones or artificially by using calcareous and aggregaous materials. Cement and lime. Following ones, the cement is used for the gain of early strength, where lime gains the strength slowly. The cement and lime colors are different. The cement and lime both is binding materials having good ultimate strength, but lime experiences less early strength as compared to cement. Manufacture of cement. The manufacturing process of cements are two: dry process and wet process. The dry process, we can see the step 1 of dry process. The materials is gathered from quarry with the help of damper of manufacturing plant. The materials gathered is having content of limestone and clay, which is calcareous component and agricultural component. Respectively, the materials gathered is about more than 80 size. Step 2: the collected materials is fed into heavy crusher, where the size of material get reduced to 60 from 80 and later this size materials is fed into light crusher, where the size reduced to 40 to 60 finally it is stored in the tank. And the last and not the least step, now the grinding material called raw mix is fed into the preheater. Then the temperature is gradually increased up to 500 degrees Celsius. Due to this increase in temperature, the raw mix get fraction into smaller size, nearly 25 Benefits of preheats: it makes the first benefit of preheaters, it makes the process fast, and second, fuel consumption is reduced because the burning time of rotary kiln is get reduced. Now the raw mix is fed into rotary kiln when the temperature is 800 to 1000 degrees Celsius. Then gradually it increased 1000 to 1200 and 1200 to 1500 degrees Celsius. They are separately zones respectively. Product obtained of size 8 to 10 mm from rotary kiln is called clinker. Here we can see the picture of rotary clinker. The rotary clinker dimensions are diameter is equal to 3 meter, length 100 meter, the revolutions and 3 rounds in 1 minute. Then C of rotary zone, the zone 1 drying zone. In the zone of the raw mix in is fractioned into more smaller size. In this zone, if there is some water or moisture exists in raw mix, then it is evaporated. Then the nodule zone or zone 2. In the zone, the major breakdown of raw mix occurs. In this zone, the calcination of limestone take place. CaCO3 limestone which is superheated and then it breaks to CaO lime and carbon dioxide CO2. Zone 3 or burning zone. Now the raw mix, which is also called nodules, is stopped down and the major chemical reactions between integrated of clinker occurs. Now from this rotary clink the product obtained is called clinker, which is composed of major and minor compounds. Then now the clinker is cooled up to temperature of 100 degrees Celsius. After cooling it is fed into tube mill where the gypsum is also added to it. The fine grinded powder having grey color is obtained, which is called cement. It is packed in 50 kg bag having 5 plus or minus 5% volume capacity of 0.035 m cube. Now after packing it is transported to dealers. Now the wet process. In a wet process, the heavier crushed material is made wet in storage tank before feeding into tube mill. In wet process, the preheater is not used. The mix obtained from thumbnail is directly fed into rotary kiln. Disadvantages of wet process: the process time is so long and the fuel consumption is more. Here we can see the flow chart of wet process. Chemical consumption of cement. The chemical compositions of cements are oxide compositions are lime CaO composition 60 to 65%, average 63%. Silica SiO2 composition percentage 17 to 25% and average 20%. Alumina Al2O3, this is 3 to 8%, average 6%. Iron oxide FeO2 Fe2O3, the compositions are 0.5 to 6%, average 3%. Magnesia Mgp, the composition percentage of magnesia Mgp is 0.5 to 4% and average is 2%. Soda or potash Na2 plus KO2 is 0.5 to 1%, average 1%. Sulfur trioxide, the composition percentage of sulfur trioxide is 1 to 2%, average 1.5%. The relative proportional of three oxide components are responsible for influencing the various properties of cement like lime, silica and alumina. An increase in lime content beyond a certain value makes it difficult to combine completely with other compounds. Coincidentally, free time will exist in the clinker and will result in an unsound cement. An increase in silica content at the expense of alumina and ferric oxide makes the cement difficult to fuse and form clinker. Now we can see the components and their details of cement. Lime CaO. If lime is provided in the excess, then the cement becomes unsound, and if it is deficiency, then the strength is reduced. Therefore changes of quick setting will be enhanced. silica. Second one is silica, SiO2. It imparts strength to the cement due to the formations of dicalcium and tricalcium silicates. If it is in excess, then the strength of the cement would enhance, therefore setting lime gets prolonged, hence it prevents quick setting. The third one is alumina, Al2O3. It impacts quick setting property of cement. If it is excess, then the strength of cement is reduced and the changes of rapid hardening would be increased. It acts as a flux and it's lower as a clinker temperature. The fourth one is calcium sulfate, CaSO4. It is a admixture. If it is in excess, then it slow down the quick setting which dominates to increase the strength. It is gypsum form. The fifth one is iron oxide, Fe2O3. It imparts colors, hardness and strength to the cement. If it is excess, then it imparts more color to the cement. Magnesia, MgO. It imparts hardness and colors yellow to the cement. If it is a small quantity and it is excess, then the imparts if soundness to the cement. Sulfur. Seventh one is sulfur. If it is reference quantity, then it imparts strength to the cement, and it is excess, then the unsoundness is increased. The eighth one is alkalis, soda and potash. Na2 Na2O plus K2O. The most of the alkalines present in raw materials are carried away by the flue gases heating, and the cement contains only a small amount of alkalis. If they are in excess in cement, then they cause a number of troubles such alkali aggregates reaction, effortness and staining with used in concrete bricks or masonry mortar. Basic properties of both compounds. Tricalcium silicate, 3CaOSiO2. Name alite, symbol C3S, percentage 30 to 50%. Second one is dicalcium silicate, 2CaO SiO2. The name of this is belite, symbol C2S, percentage 20 to 45%. The third one is tricalcium aluminate. The formula of tricalcium aluminate is 3CaOAl2O3. Name Silite, symbol C3A, percentage 8 to 12%. And fourth one is tetracalcium aluminoferrite. Formula 4CaOAl2O3Fe2O2. Name is phyllite, symbol C4AA, percentage 6 to 10%. Now we can see the compositions of both compounds. First one is tricalcium silicate, C2S, tricalcium silicate. It produces faster rate of reaction with greater heat evolution. It impacts early strength to the cement and also contribute good for ultimate strength. If it is excess, then the rapid hardening enhance. Dicalcium silicate, C2S. It hydrates slowly and impacts ultimate strength much. The C2S has less heat of hydration, therefore it is resist against chemical attack. Third one is tricalcium aluminate. It impacts fast reaction with water and it produces very high heat, therefore it impacts more towards rapid hardening. If C3A would be more than impeded setting or flash set would be enhanced to prevent the flash setting, gypsum is added to it during manufacturers. Here we can see the rate of hydration of pure compounds, time scale and the heat of hydration. Rate of heat of hydration evolution of both compounds it equal amount of each considers will be following disorders: Ca3 to C3S to C3AF to C2S. Here the curvature of development of strength of pure compounds. Hydration of cement. The chemical reactions of cement with water is referred as hydration of cement. The reaction of cement and water is exotic reaction of heat is liberated in a considerable quantity and This liberated heat is called heat of hydration. The water added to the cement will leads to evolution heat. The C3S and C2S reacts with water during hydration to form a calcium silicate hydrate along with CaOH whole 2. The reduced sulfate attack. Sulfur contains in water. So first and second one is C3A and C4AF. And then we can see the types of cements. There are different types of cements that are classified by the Bureau of India Standards, BIS. The first one is ordinary Portland cement. The grades are 33 grade, 43 grade and 53 grade. The second one is rapid hardening cement. Third one is extra rapid hardening cement. Then after low heat Portland cement. Fifth one is Portland slag cement. Then Portland pozzolana cement, which is normally used in every casting or every construction of building. The seventh one is sulfate resisting Portland cement. This cement is sulfate resist. The white Portland cement, colored Portland cement. 10th one is hydrophobic cement, high alumina cement, super sulfate cement. And last not the least one is special cements like masonry cement, air entraining cement, explosive cement, oil well cement. So here we can see the ordinary Portland cement or OPC. It obtains by Pulo Aguirre and Cladikias materials in correct proportions. The number of 33 grades OPC 33 grade, OPC 43 grade and OPC 53 grade. The OPC full form is ordinary Portland cement. It is used in general concrete construction where there is no exposed to slumps in the soil or in groundwater. The second one is rapid hardening cement, RHC. Here we can see like we can the when here like the name of rapid hardening cement, so we can understand that the cement is rapid hardening the the concrete work. It is finer than ordinary Portland cement. As we can see that it contains more C3S and less C2S than the ordinary Portland cements. The first day strength of the cement is equal to the third day of OPC with the same water cement ratio. The main advantage of rapid hardening cement is the shuttering may be removed much earlier, thus saving considerable time and expenses. This cement is now used in every work. Rapid hardening cement is also used for road work where it is imperative to open the road traffic with the minimum delay. Cost of rapid hardening cement is nearly 10 to 15% more than OPC. This is natural. And the last one, it can be safely exposed to frost as it matures more quickly. The third one we can see extra rapid hardening cement. It obtained by mixing calcium chloride with rapid hardening cement. Addition of CaCl2 or calcium chloride impacts quick setting properties in extra rapid hardening cement. The acceleration of setting, hardening and evolution of heat in the early period of hydration makes the cement very suitable for concreting in cold weathers. The first or second strength of extra rapid hardening cement is 25% more than that a rapid hardening cement. The gain of strength disappears with age of 90 days. Strength in of extra rapid hardening cement and the rapid hardening cement are nearly the same. Use of extra rapid hardening cement is prohibited in pre-stressed concrete construction. Maximum time of using the concrete is 20 minutes. More mixing, transporting, placing of compactions. Low heat cement LHC. It is Portland cement which is obtained by reducing the more rapidly hardening compounds C3S and C3A and increasing C2S. As per the Indian standard specification, the heat of hydration of low cement shall be as follows: 7 days, not more than 65 calories per gram, 28 days, not more than 75 calories per gram. Since the rate of gain of strength of his cement is slow, hence adequate precautions should be taken in the use of such as the rigors of removal, formworks, etc. LIC or low heat cement is used in massive construction works like embankments, relating walls, dams, etc., where the rate at the which the heat can be lost at the surface is lower than at which the heat is initially generated. It has low rate of gain strength, but the ultimate strength is practically the same at the ordinary Portland cement. Portland blast furnace slag cement. The cement is made by ingredient Portland cement, clinker, and granulated blast furnace slag. The proportion of slag being not less than 25% or more than 65% by weight of cement. The slag should be generated blast furnace slag of high lime content, which is produced by rapid quenching of molten slag obtained during the manufacture of pig iron and blast furnace. And here we can see Portland Pozzolana cement or PPC. It can be produced either by grinding together Portland cement clinker or with the addition of gypsum or by blending unfirmly Portland cement on the fine pozzolana. It has lower rate of development of strength than OPC. It evolves less heat and its initial strength is less but final strength is equal to the OPC. OPC ordinary Portland cement. The average compressive strength of cement mortar is 1:3 at day 1 1 hour 16 minimum at 7 day 7 2 hour at 28 day 4 hour. Then we can see acid resist cement. Acid resist cement is a composed of the following acid resist aggregates such as quartz, quartzites, etc. Additives such as Na2SiF6, solution of sodium silicate or soluble glass. The addition 0.5% licensed oil or 2% or cerusit increase resistance of water also. Then we can see sulfate resist cement and colored cement, which is white cement also. And then we can see high alumina cement, which in the cement of the C2C3A, the composition of Portland cement, which is resist the sulfur attacks and chemical attacks. Then we can see quick setting Portland cement, masonry cement, super sulfate cement, and air entering cement, hydrophobic cement. There are tests of cements which are field test for cements. Color gray color with a light greenish shade. Physical properties: cement should feel smooth when rubbed in between the fingers. If hand is inserted in a bag or heap of cement, it should feel cool. If a small quantity of cement is thrown in a bucket of water, it should sink and should not float on the surface. And the percentage of lumps should be free from lumps. That's it. Thank you.